Hello again, this is Dave with OC Astronomy, and we're going to be looking at Openstax Chapter 9 today. We're going to be looking at the Moon and Mercury, and they're very similar, or at least they look similar. They are both covered in craters, and they both have kind of a gray, crusty looking outer layer, and they don't have an atmosphere. But they do have some important differences that we'll find out in a little bit. Both the Moon and Mercury are very small. Their masses compared to the Earth are quite a bit smaller. The Moon's mass is only 1/100th of the Earth's mass, and Mercury is only 5 times bigger. It's only 5/100ths, so 5 parts out of 100, the mass of the Earth. So they are both really small. And if you compare the gravity, though, Mercury has a little bit different gravity because it has a denser core. Mercury's gravity is about 1/3 of that of the Earth, and the Moon's gravity is about 1/6 that of the Earth. They both have a crust around the outside of them of silicate rock, and silicate is like the stuff that is sand is made out of or glass is made out of. It's kind of a grainy particle, and it can also form into rocks as well. Both of those have a silicate rock covering, and they're both covered in craters. But one of the differences, let's start looking at Mercury first, is Mercury has a large amount of metal in its core. In fact, Mercury, if you picture the moon, and picture the moon, instead of being a ball of rock, picture it as a ball of metal. And if you had a ball of metal the size of the moon, that's how big Mercury's core is, of iron and nickel. And then on the outside of Mercury, it has a thin shell of silicate rock. So it has a huge iron core and then a shell of silicate rock on it, which is quite a bit different from we'll see about the moon. It has a lot of craters on the outside of it because Mercury, being really close to the sun, is going to be in the central zone where the sun is pulling all of the little small piece parts of the solar system are going to be pulled towards the sun. So you get things like small asteroids and comets and things going at the sun. And with Mercury being so close, it gets pelted with all that debris as that debris gets rained in towards the sun. So Mercury is covered in craters, and that's where they think it comes from, is just being so close to the sun. Another consequence of being so close is that if you have a small body that's going around a larger body, one thing that can happen is the forces of tides on the planet, or the force of gravity between the two as it goes around. The smaller one of the bodies can get it's called tidal lock, and that means that it doesn't spin around as much as it goes around. It doesn't whirl around as it goes around. It spins really slowly as it goes around, and it actually gives the impression of the same face facing towards the larger body the entire time. With the moon, our moon goes around us one time for every one time it turns around. And because of that, we see the same face of the moon the entire time as it's turning around, because it's making one turn for every one revolution. Mercury is kind of different. It turns twice for every 3 times around. It has a really weird 2/3 resonance. But this resonance means that Mercury kind of slowly turns like a rotisserie chicken as it goes around the sun. As a result of that, you get temperatures on the daylight side of Mercury at noon. So noon for us takes half a day to get around. Well, noon on Mercury takes 30 Earth days. To go from midnight to noon takes 30 Earth days, and then it takes another 30 days to get back around to midnight. So it's turning very, very slowly. On the noon side, it can be as hot as 430 degrees Celsius, while on the midnight side, it can be as low as negative 170 degrees Celsius. And so it has like a 600 degree temperature swing between the day side and the night side, which is really, really strange. We've learned a lot about Mercury from a couple of different methods. One is you can observe it visually with a telescope, and you can see that it doesn't have an atmosphere and things like that. We've observed it with radar, and sending radar signals at it and then listening with radio telescopes is one way to tell how fast it's moving, because they can look at the Doppler spread of its spectral lines, and they can see when it bounces off and comes back, they can see from the spread how fast it's rotating, and that's what lets them know that it rotates so slowly. We've also sent some space probes. In 1974, we sent a probe called Mariner 10, and it was able to beam back some pictures of the surface. They weren't really super high res, though, but they did give us an idea of what the surface of Mercury looked like. And then in 2004, so 30 years after Mariner 10, we sent another probe called Messenger, and Mercury being the messenger of the gods, that's a good name for it. And the Messenger probe sent back some good high-resolution photos and some other measurements that it was able to take. Because of Messenger's information that it sent back, that probe, we were actually able to find out that Mercury has some water on it near the poles. Now, as hot as it gets, 430 degrees Celsius, you wouldn't think that Mercury would have any water left because it would all boil off and blow away. But there is a little bit on there because it's trapped inside deep craters in the poles. And they think that that's why there's a little bit of ice there. Probably it got hit from impact of comets. We talked about all the debris coming in, and a comet could have hit it and supplied that water, and then because it was maybe hit it in a deep crater, in the bottom of that crater, some of that ice and water might have stuck around. And they do think that there is some water on there, but not very much. Now, the one thing that we haven't done with Mercury is send people there, because it would not be very smart to send astronauts to someplace that gets to be around 430 degrees Celsius. We would probably cook. And then also, if we sent astronauts down to Mercury, it would take a lot of rocket fuel to get them back. So we would have to send them with a lot of rocket fuel for them to be able to blast off with enough speed to come back and join us at Earth. And it would be really, really hard. So we haven't sent people there at all. We've only sent robots. Now, contrast that with the moon. We have learned some things about the moon by sending people there. In fact, the first couple of Apollo missions, yay for the Apollo Saturn rocket. The first couple of missions to the Apollo, we basically just went and planted a flag and said, yay, we're here. But then a little bit later after that, we started sending scientists that were trained in geology. First, they trained the astronauts in geology, kind of cross-trained them. And then on the last couple of missions, they actually sent some geologist scientists personally to go be astronauts and to land on the moon, which is pretty fascinating. From what they've been able to find about the moon, they've brought back a lot, literally tons of rocks. And from studying those rocks, they are almost all silicate rocks. So rocks made out of that kind of the stuff that glass is made of, silicon sand. And there's almost no water there, but they also have found a little bit of water like Mercury. The astronauts didn't find it, but we did find it with some probes that we sent to go around the moon and map it really closely. They were able to find a little bit of water in those craters. Now, what they've been able to find about the moon is that it has no iron core. One way they found this out is they landed seismograph equipment on the surface of the moon, and then interestingly, when they sent astronauts there, they put down seismometers first, and then another mission when they sent them, they crashed one of the upper stages of the Apollo, one of the middle stages. They actually crashed it into the moon, and from its impact, it rang it like a bell. And from looking at those impacts and the different seismometers that were left around, they were able to conclude that there's no iron core in the center of it, because from the impact and the way that the waves spread across the moon, they spread in a particular pattern that told it does not have an iron core. And so how do they think the moon got here? Well, they think the moon might have been a planet about like Mercury whenever the solar system was forming, but that original planet collided with the Earth, and then the Earth and the moon had kind of some debris that was left over, and then some debris came off and became the moon, and a lot of the stuff that was in that original impacting planet actually went into the Earth and was absorbed by it. There's actually an analogy. There's something called an armor-piercing bullet. that they use to fire at tanks in war. And one of the things is it has a metal coating like a normal bullet, but then on the inside it has a seed, a really high density thing called depleted uranium that's really, really dense. So what happens is if you have the armor of the tank here, you get the impact which heats that area up and it kind of melts it, and then the momentum of that uranium seed will go through that melted metal and then go inside the tank, and that's what actually explodes the tank. So whenever they hit a tank with a shell, it doesn't actually blow up the tank with explosives. It blows it up by hitting it, and that little melted area lets the heavy, dense metal go through that melted zone and to the inside of the tank, where it hits the shells and the gasoline that are on the inside of the tank, and that's what actually blows the tank up. And so in a similar way, that's what probably happened with the Earth, and this object that was probably a lot like Mercury that had a metal core came and hit the Earth. The rock that was on the outer core of it hit the Earth, but then its own metal core pierced through the Earth, and so our metal core that's inside the Earth probably doubled in size because of all the iron that came in from that original impactor and came in and gave us a little bit larger iron core. And then the stuff that was left on the outside was like floating around bits in space, and then it finally coalesced into a moon. And so the moon rock that we've been able to find has a lot of the same characteristics as the silicate rock that's on the Earth. In fact, one of the things that is very similar is it has an isotope of oxygen and a breakdown of radioactive oxygen. And that isotope of oxygen is found in the same percentages on the surface of the moon that's on the surface of the Earth. And so they think that the rock that the moon is made out of came from the rock that was on the surface of the Earth. And so that's how it formed. Anyway, that's the Moon and Mercury in a nutshell. Mercury has a large iron core and is very dense iron core and a covering of rock, whereas the Moon is almost pure rock with very little to no metal core, but they're both made out of silicate rock. They both show a lot of craters, which tells us that over the history of the solar system, there have been lots of little particles that have gone around and smashed into those things, and probably we've seen a lot of craters on the moon, and probably just as many things would have impacted Earth, but we have a covering of an atmosphere on Earth, and the thick atmosphere helps burn up those rocks before they hit the surface. And we don't have we also have a little bit more geological activity, so we don't show quite as many craters on Earth as there is on the moon. So anyway, there's the Moon and Mercury in Chapter 9. Hope you do well on the quiz, and we'll talk to you later.